Okay guys, here's another one. It's another energetics question. We have enthalpy of combustion this time. Combustion just meaning burning in oxygen. Now we've got three equations. I'm going to label them 1, 2 and 3, and then the final equation, what we want to achieve is this. So basically these three equations we want to rearrange to all add up to that final equation. Let's call that number 4, right? And we have, instead of values, this time we just have x, y and z. Okay, so let's deal with this now. So what I can see here immediately is you have the C4H10, the butane. Okay, now as you can see, equation 3, it's on the product side, so I'm going to flip it. Okay, so let's write that down. Let's deal with equation 3 first. So let's flip this. C4H10 is flipped and it becomes 4C5H2 plus, so that's the products now. So it's been flipped. The immediate thing is we have 2 moles of butane. At the moment we only have 1, so this needs to be changed. So we need to put 2 moles there. That now becomes a multiple of 2. So let's erase this and the 5, and we're going to change these to, instead of it being, as we said before, 4, it becomes 8 carbons, and that becomes 10 hydrogen. Okay, so we flipped it and multiplied by 2. So the delta H situation is now minus 2Z. Okay, so next thing, let's look at hydrogen. Okay, hydrogen, as you can see, is on the product side on both equations, but as you can see, we only have 1 mole of hydrogen as products here, so we need to multiply it by 10. So we write the same equation out. Number 2, we're going to go 10 H2 plus 10 times half a mole of oxygen, which would equate to 5 oxygens. Now I'm going to put 10 moles of H2O. This now ticks off the hydrogen, or the H2O, sorry, the water that's been produced. So what we've done here is multiplied by 10. So the delta H for this now is 10 Y. Okay, last but not least, number 1, let's see what we have in common here. Again, we need carbon dioxide, which is on the product side. We don't need to flip this equation, but we have 1 mole in the products, and in the equation for the combustion we have 8, so we need to multiply by 8. So this becomes 8 carbon plus 8 oxygen molecules plus 8 CO2 molecules. So we've done is multiply the delta H value by 8, so this will become 8x. Okay, let me just make sure this is working. So it's 8x. Now let's add these values up. So we would be saying 8x plus 10y minus 2z. Okay, so we've got our initial equation. One thing I just want to do is make sure that equation is right first of all. So different color. What can we remove from both sides? If we look at our equation, 8 carbons can go. Okay, the 10 hydrogens can go because they're equal on each side, and then everything adds up as expected. That's correct. Now 8x plus 10y minus 2z. You might be mistaken in thinking, okay, that's C, but we can simplify this equation. There's a common multiple. So if we divide everything by 2, because that will be the lowest number, right? So it would be 4x plus 5y minus z, which is option A. Let's just check that. There you go. Now that resolves that. It just requires a bit of practice looking at what's common, to summarize what's common in the equations, rejigging in terms of flipping the equations if we need to get the products and reactants in the right places. Remember, we need to do the same with the energy enthalpy values, and then add everything up and we get our answer. Okay guys, see you in